Welcome to the Introduction to Nonparametric Statistics.
When learning statistics, we learn about descriptive statistics and inferential statistics. In most classes, from the beginning onwards in inferential statistics, we learn to calculate z-test, t-test and do two-sample t-test. These are some examples for parametric tests. Parametric tests are tests that are based on the samples that follow certain assumptions called parameters. These parametric assumptions include that samples are randomly drawn from a normally distributed population, consist of independent observations except for paired values, consist of values on an interval or ratio measurement scale, have respective populations of approximately equal variances. The sample size are adequately large, approximately resemble a normal distribution. If any of the above mentioned assumptions are violated, a parametric test cannot be performed. In such cases, nonparametric tests are performed. Nonparametric tests are tests that have fewer required conditions to be satisfied and the population is not required to follow a particular distribution. Further, categorical as well as rank data can be used for analysis. If we consider few common characteristics to nonparametric techniques, they are: it has fewer assumptions regarding the population distribution, sample size is often less stringent, scale of measurement may be nominal or ordinal, independence of randomly selected observations except when paired. Primary focus is on ranked ordering of frequencies of data. Hypotheses are posed regarding ranks, medians of frequencies of data. When considering nonparametric tests, there are advantages as well as disadvantages of using nonparametric tests. The advantages of using nonparametric tests are that the tests can be performed quickly and easily without the aid of technological devices. It requires few assumptions about the underlying populations from which the data are drawn, and they are free from distribution. Nonparametric techniques are usually easy to perform and apply than their parametric counterparts. Nonparametric procedures are applicable in many situations where normal distribution theory procedures cannot be utilized. Nonparametric tests are relatively robust and can be used effectively for determining relationships and significance of differences using behavioral research methods. Quantitative data can be used as well as qualitative data for nonparametric tests. When considering disadvantages of nonparametric tests with respect to parametric tests, nonparametric tests are less efficient and less robust than parametric tests. It is hard to organize data when the sample size n is large, especially when ranking data. Unavailability of tables for nonparametric tests. The tests can be misused due to lack of assumptions and use of small samples. Graphing calculators and statistical software often do not have dedicated procedures for the test The test can be used when parametric tests can be performed due to quick and easiness, leading to misuse and reduced level of accuracy. In situations where parametric tests cannot be used, the following non-parametric procedures can be used instead. In situations where one sample t-test and paired t-test cannot be used, we can use sign test or Wilcoxon sign rank test. For situations where unpaired t-test or two sample t-test cannot be used, we can use non-parametric counterpart Mann-Whitney U test. For two-way ANOVA, we can use Friedman rank test, and instead of one-way ANOVA, we can use Kruskal-Wallis test. Thank you for listening to the introduction of non-parametric statistics. I hope you enjoyed. Thank you.